The last section in Chapter 5 is about the perpendicular bisector theorem and the angle bisector theorem. Before I go into what the theorem says, I want to make sure you understand what a perpendicular bisector means. A perpendicular bisector is for a line segment, and it cuts the line segment, bisector, into two equal line segments, and it is also perpendicular to the original line segment. So it cuts it in half and it's perpendicular. What the theorem says is that if you have any point on the bisector, on that blue line segment, it will be the same distance away from the two endpoints. So any point on the blue line segment will give you the same distance to the two endpoints of the red line segment. In words, so this is something that you could write down, the perpendicular bisector theorem says a point is on the perpendicular bisector of a segment if and only if it is the same distance from the endpoints of the segment. This is a two-way arrow here. It means you can use this theorem in both directions. So if I know that a point is equidistant from my two endpoints of my segment, then I know that that point is also on the perpendicular bisector. So I'm going to read it one more time. A point is on the perpendicular bisector of a segment if and only if it is the same distance from the endpoints of the segment. So if I know either one of those two things, I know the other one. Okay, so here's my first example, and this is my thought process on that first example. My first thought is I noticed that EF and ED or DE are the same length. They're both 13. Okay, so once I notice that, I know that that means that EG is a perpendicular bisector of FD because E is the same distance away from F and D. And since I know it's a perpendicular bisector, I know that it has to cut the line segment into two equal parts, which means that I know that 5x minus 17 has to equal 3x plus 1. So I set that up as an equation so that I can figure out what x is. So I'm looking at 5x minus 17 equals 3x plus 1. I'm going to subtract 3x, so I get 2x minus 17 equals 1. I'm going to add 17 to both sides, so I get 2x equals 18, and then I know that x is equal to 9. Once I know x is equal to 9, I know that FG is 5x minus 17, so in order to figure out what FG is, I'm going to do 5 times 9 minus 17, or 45 minus 17, or 28. So this is how you use the perpendicular bisector theorem one way. This is knowing that my point is the same distance away from my endpoints. Then I know that it's on the perpendicular bisector. I'm going to give you a minute to try example 2. So pause the video and give the example 2 a try before you restart. Okay, so for example 2, what I did was I noticed that S is on the perpendicular bisector. Since it's a bisector, I know that the two halves of that line segment TR are equal to each other, so TU is equal to UR. And then I use that fact to solve for X. I started by subtracting 2X. Then I added 30 to both sides, so I got that x is equal to 18. Once I know that x is equal to 18, I use that to figure out the length of TU. TU is 2x plus 24, so I'm going to plug 18 into that expression, and I get 36 plus 24, or TU is equal to 60. Example 3 is the other way of thinking about this. Looking at the diagram, I know that BD is the perpendicular bisector of AC because I noticed that it's perpendicular, and I also noticed that it cuts AC in half. Knowing that it's a perpendicular bisector and that B is a point on the bisector, then I know that BC and AB must be congruent to each other because of the theorem. So that tells me that I can solve for 6x plus 11 is equal to 11x minus 9. So I can subtract 6x from both sides and I get 5x minus 9 is equal to 11. I can add 9 to both sides, so I get 5x is equal to 20. So that means that x is equal to 4. Once I know x is equal to 4 and I want to find AB, I can use that fact to say 11 times 4 minus 9, and that's going to be 44 minus 9, or 35. So I know that AB has to be 35. So I'm going to have you pause the video and then you can do example 4. So in example 4, I know that DB is the angle bisector, which means that AB and BC have to be the same length. I set them equal to each other, and then I subtract 3x, then I add 16, and then I divide by 4, so x is equal to 6. Once I know x is equal to 6, I can use that fact to find AB, because AB is 3x plus 8. I can plug 6 in, so AB is 3 times 6 plus 8, or 18 plus 8, which is 26. Okay, I'm going to leave example 5 for you to try, and you have to use the diagram, the equal signs on the congruent line segments on the diagram, and then also this perpendicular bisector theorem to solve for x and y. I'm going to not go through this example. This is here for you to try. The angle bisector theorem says that the point is on an angle bisector if and only if it is the same distance from both sides of the angle. So if I pick a point on the angle bisector and then I measure the distance from that point, the shortest distance is going to be perpendicular. So if I measure the distance from that point to the side, and then I measure the distance from that point to the other side, then I know that these two line segments will be the same length. I also know that if those two line segments are the same length, if that distance is the same, then I know I'm on the angle bisector. So this is again a theorem that goes both ways. You can use either part because it's an if and only if. It's a biconditional statement. Okay, so number 6, I'm going to try to find the length of KL. My first thought is I noticed, because the angles are marked, I noticed that JL bisects angle MJK. And since I know that that's the bisector, I know that KL has to be equal to ML, because L is the same distance away from the two sides. And so I know that 2x plus 3 has to equal 4x minus 11. So I'm going to use that to algebraically find what x is. I'm going to subtract 2x, so 3 equals 2x minus 11, and then I'll add 11. So 14 equals 2x, divide by 2, So x equals 7. And once I know that x is equal to 7, I can figure out that KL has to be 2 times 7 plus 3, or 14 plus 3, or 17. I'm going to let you solve example 7. So please pause the video and solve example 7. So for 7, I know that HI is 7, and I know that IJ is also 7, which tells me that GI is the angle bisector. So I know that these two angles have to be congruent. I was told that HGI is 25, so that means that IGJ is also 25. And so the measure of angle HGJ would have to be 50. I'm going to leave 8 and 9 for you to solve, so 8 and 9 are there for you to try. All right, thanks so much. Bye.